Hey, what is up, everybody? The following information is really important if you want to know a lot about Henry Moseley, so do what Harambe would and pay attention to this video. Thank you. In November 23, 1887, Henry Gwyn Jeffreys Moseley was born in Weymouth, England to a very well-educated family. His father, who was also named Henry, was a professor of anatomy and physiology. His mother, Annabelle, was the daughter of a barrister who later changed her career path to become a mollusk biologist. So basically, she studied snails like Gary from SpongeBob. With his success at grade school, he ended up winning a scholarship to Eton College, which to this day is one of the most prestigious schools in Great Britain. While at Eton College, he ended up winning many of their physics and chemistry prizes, putting up one heck of a resume. Shortly after, in 1906, Moseley was accepted to Oxford's Trinity College. There, he disappointed himself. He was suffering badly from hay fever when he sat his final exams. He ended up getting a second-class honors degree in physics and was not content, as he was really hoping for a first degree like he had expected. Four years later, he transferred to the University of Manchester to work in Ernest Rutherford's research group. While at Manchester, Moseley had a two-part job, to teach physics and carry out research work. However, he quickly discovered that he did not enjoy the teaching part of his job. He had to slog every day through his dislike of teaching until Rutherford grew impressed of his work and granted him a fellowship. Accepting it allowed Moseley the ability to focus solely on his research. Moseley became familiar with the field of radioactive chemical events while working in Rutherford's group. In 1912, he attempted to use high positive voltages to pull beta particles back into their radioactive source. He did this by insulating the radium so that it would become increasingly positive as the beta particles carried away the negative charges. If the radium could reach an electrical potential of 1 million volts, then even the most energetic beta particles would be pulled back into the source as they were emitted. Unfortunately, the degree of perfection needed in insulating the radium could not be achieved. On the bright side, he was able to generate 150,000 volts on a radioactive source. This ended up being the world's first atomic battery. Moseley had learned from the Bragg brothers that when high-energy electrons hit solids like metals, the solid emits X-rays. Interested in their discovery, Moseley sought out to study the X-rays emitted by solids to learn more about what goes on inside atoms. He quickly put together an experimental apparatus to shoot high-energy electrons at different chemical elements and measure the wavelength and frequency of the resulting X-rays. In this experiment, he discovered that each element emits X-rays at a unique frequency. He also found he could get a straight line graph by plotting the square root of X-ray frequency against elements' atomic numbers. This meant that he had discovered the difference between elements, which were the number of protons that they have. So for example, this meant that an element with one proton was hydrogen, two protons were helium, and so on, so forth. With this discovery, Moseley had rearranged the elements in the periodic table by the number of protons rather than atomic weights like some had thought. It cleared up questions about the table that made scientists iffy about its legitimacy for decades. When World War I began in 1914, he enlisted as a volunteer in the British Army's Royal Engineers. His family and fellow scientists pleaded for him to continue his research instead of joining, but he was motivated to serve. With the rank of second lieutenant, Henry Moseley was killed in battle at the age of 27 in Gallipoli, Turkey on August 10, 1915.